Welcome back to channel. Today, we will break down each part of an HPLC system, explaining what it does and how it contributes to this powerful analytical technique. Introduction to HPLC. HPLC is used extensively in labs worldwide to separate, identify, and quantify compounds in mixtures. Its ability to achieve high accuracy and efficiency makes it invaluable in industries like pharmaceuticals, environmental testing, and food safety. An HPLC system is made up of several essential parts, each with a specific role to ensure precise and accurate results. The solvent reservoirs. These containers hold the mobile phase, which is a liquid solvent or mixture of solvents that flows through the HPLC system. The choice of solvent depends on the specific analysis and the nature of the sample. Multiple reservoirs may be used to mix solvents automatically for gradient elution, which helps separate complex mixtures. The Degasser. Dissolved gases in solvents can create bubbles that disrupt the HPLC's flow and cause baseline noise in the data. A Degasser removes these gases, ensuring a stable and consistent flow of solvent through the system. Most degassers work by passing the solvent through a vacuum chamber that removes gases effectively. The pump. One of the most critical parts of an HPLC system is the pump. The pump drives the solvent from the reservoir through the system at a consistent flow rate and pressure, typically between 1000 and 4000 psi. This high pressure is essential for pushing the solvent through the tightly packed column, allowing efficient separation of the sample components. There are different types of pumps, like isocratic pumps, which maintain a constant solvent composition, and gradient pumps, which adjust the solvent mixture during the run for better separation. The injector. Then we have the injector or autosampler. This is where the sample enters the mobile phase. In a manual injector, an operator injects the sample directly into the system, while an autosampler automates this process, injecting precise volumes at regular intervals. The accuracy of the injector is crucial, as even slight deviations can affect the consistency of results. The column, often called the heart of the HPLC system. Inside the column, separation occurs as the sample compounds interact with the stationary phase. The choice of column depends on the analysis requirements, including length, diameter, and packing material. The stationary phase's polarity can vary depending on whether a normal phase or reverse phase method is used. And it's the interaction between the sample and stationary phase that determines how components are separated. The column oven. The column oven maintains a stable temperature during the analysis. Temperature control improves separation consistency and reproducibility. For example, when working with compounds sensitive to temperature changes, the column oven keeps conditions constant, leading to more reliable and repeatable results. The detector. After the sample passes through the column, it reaches the detector. The detector identifies and quantifies the separated compounds, sending a signal that corresponds to the concentration of each component. Common types of detectors include UV-vis, refractive index (RI), and fluorescence detectors, each suited to different types of analyses. The detector data is then converted into peaks on a chromatogram, showing us the retention times and concentration of each compound. The data system, chromatography software. The final part of the HPLC system is the data system or chromatography software. This software records and processes the signals from the detector, creating a chromatogram, a visual representation of the separation. The software measures peak areas, calculates retention times, and often quantifies compounds based on calibration curves. Advanced software can also analyze complex chromatograms, automatically identifying compounds in large datasets. How HPLC parts work together. Each part of an HPLC system plays an essential role, working together to deliver accurate and detailed analyses. Starting from the solvent reservoirs, the mobile phase travels through the Degasser to remove gases. The pump maintains a high-pressure flow to the injector, where the sample enters and moves to the column for separation. Temperature is controlled by the column oven, and as compounds exit the column, the detector identifies them, with the software recording all data. This synergy of parts makes HPLC one of the most precise and reliable methods in analytical labs. Maintenance and tips for each part. Maintaining your HPLC system is crucial for consistent results. Here are some key tips. Solvent reservoirs. Change solvents regularly, and ensure they're filtered to prevent particulate buildup. Degasser. Keep an eye on the degasser's efficiency and replace vacuum membranes as needed. Pump. Regularly check seals, as they're exposed to high pressure and can wear over time. Injector. Clean the injector needle or autosampler to prevent carryover from previous samples. Column. Flush with compatible solvents between runs to extend its lifespan and prevent cross-contamination. Detector. Clean windows and check for any drift in sensitivity, as detectors are highly sensitive to contaminants. And that's an in-depth look at each part of an HPLC system. Understanding each component and its role helps ensure you're getting accurate, reliable results every time. If you enjoyed this video and found it helpful, give it a thumbs up, subscribe, and hit that bell icon to stay updated on all our upcoming video. Thanks for watching, and see you next time.